Okay, hi everyone. Today we're going to explore a little bit about standard form, 3.6 standard form. And another name for standard form, right, is actually called our scientific notation. Alright, so what do we mean by expressing our numbers in scientific notation is usually we'll express it in just a number, right, the number a times 10 to the power of something. Okay, now this a, the condition for this a, right, has to be between 0, has to be between 1, right? It can be 1, right? It has to be between 1 to 10, and then but it cannot be 10, right? Because if it is 10, you can write it as 1 times 10 to the power of 1. Okay, and then this notation over here is our standard notation. So let us take a look at a few examples. Okay, let's take a look at a few examples. So example, the first one, we have around like the world population as of 2020. So it will be like this. Can you see this? Okay, yeah, something like that. So what is this actually? We can write this as something like 7.8. It is not approximate, it is equals to 7.8 times 10 to the power of 9. Okay, we can write it something like this because we can express this as 7.8 times 1 billion. Right? And what is actually 1 billion? 1 billion is actually 10 to the power of 9. Okay, so before we go on, right, we will need to find out first what are the different powers of 10. So example would be, let's say 10 power 1 would be just 10. 10 power 2 is 10 times 10 will be 100. 10 to the power of 3 is 1000. 10 to the power of 4, 4 zeros behind. 10 to the power of 5, 5 zeros behind. Okay. Can you see the trend roughly? Right? And if you go the other way, 10 to the power of 0 is 1. Right? 10 to the power of negative 1 would be 1 over 10 or 0.1. Okay? 10 to the power of negative 2 would be 1 over 10 squared, so 1 over 100, 0.01. 10 to the power of negative 3, it is 1 over 10 cubed, so this is 1 over 1000, so 0.001. So you can see actually there's also following the number of zeros over here, 1 0, 2 0, 3 0. Okay, so we'll be making use of powers of 10 a lot over here. So hopefully after this you really get to know the difference between the positive and negative index. Yeah, especially for powers of 10. Right, the next one over here would be 0.0000000000053. So this one would be would be equals to 5.3. It is I need a number between 1 to 10, right? 5.3 to the power of negative 11. Okay, to the power of negative 11. Okay, so actually this standard form, right, is allowing us to write numbers which are very big or very small in a very concise manner. And how do we see whether a number is really big or really small? We just need to compare this order of magnitude, the 10 to the power of 9 or 10 to the power of negative 11. For 10 to the power of 9, it is going to be a very big number. It's going to be in the billions. For 10 to the power of negative 11, you have 0.00011 zeros trailing before you get your 3. Okay, so with this, let us take a look at our textbook examples. Okay, over here at the standard form, and let's explore a little bit down here. Okay, at page 78, some discussion part. Now over here we have 1, 2, 3, 4. We have Singapore's population 5,850,000. So actually when we even if we say this, we say 5.85 million, right? So actually 5.85 million or 5,085,000. So actually if you want to like write this out, is 5.85 times 10 power 6. Okay, this also same thing, 149 million. So yeah, we can write this as 1.496 times 10 power 8. Alright, now this one right over here will be very small, 0.000, and as you can see this is 10 to the power of negative 10. Okay, mass of an oxygen atom, you have 26 zeros over here. Really small quantities. So example 1, the examples in 1 and 2 involve very large numbers. What do you observe about the powers of 10? The powers of 10 are positive, so the powers are positive. Alright, then the examples in 3 and 4 are really small number. What do you observe over the powers of 10 in each standard form? The powers are negative. Right? And let us complete the last column for 5 to 7. Alright, so for the speed of light, I think some of you may have learned in science, this is 300 million meters per second. We can write this as 3. Now, a quick way to do this is you find where's the decimal point over here. Right? So, as long as your decimal point moves to the left, right, you need to add your power. So 1, 2, 3, 4, 5, 6, 7, 8. Right? It moves 8 steps. So over here I have 3 times 10 to the power of 8 meters per second. Alright? Now in the same way, I'm going to use this decimal place over there. Right? Use this decimal place over here. I'm going to move it to get a number to behind 3. Because my standard form is just behind 3. So 1, 2, 3, 4, 5. I move 5 steps. So over here it will be negative 5. Okay, so if you move to the left, it will be positive. If you move to the right, it will be negative. Now let me do the last one in the same manner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So this one would be 10 to the power negative 23. Right, so this is a mass of a water molecule. Right, 10 to the power negative 23. And as you can see over here, this is something like your Avogadro's constant. Do you see that? Your Avogadro's constant. Okay, which is 6.02 times 10 power 23. Okay, so it's very close to that order. Alright? Okay, so without further ado, right, let us move on to the next segment. Okay, so before we move on, let me just write down a remark, okay, or a shortcut. Alright, so if you need to move your decimal to the left, okay, if you move your decimal to the left, what happens is your power of 10 will increase, okay, by the number of steps you move to the left. Then if the decimal move to the right, okay, this is just a shortcut, okay, right, your power of 10 would decrease, would minus. Okay, so this is a shortcut. It's not, instead of a remark, let me put here shortcut. Okay, alright, so with that in mind, let us go on to the next portion, which is our practice now 15 in the next page. Okay, so practice now 15. Okay, sorry, what page was this? 79. Okay, page 79. Okay, so with this, right, let us take a look at 1, right? Let us convert numbers into standard form. So we have 5300000. So this would be 5.3, and you see that my decimal point is 3. So how many steps do I need to move my decimal place? I need to move 1, 2, 3, 4, 5, 6 steps. I need to move 6 steps over here. Okay, so over here will be 10 to the power of 6. A very quick way to do so, right? For B, I have 600 million. Okay, so I'm going to have a 6 now, and then 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this would be times 10 to the power of 8, like that. Okay, and then especially in science, we will be using a lot of standard form, really. When it comes to, chemistry, when it comes to physics, yeah, there's a lot of standard form. Okay, So yeah, you may want to like learn well so that you are able to understand and make sense of the numbers there. Alright, for C we have 0.000048. Right? So how many steps do we need to move our decimal? 1, 2, 3, 4, 5. 5 steps to the right. So this would be 4.8 times 10 to the power of 5, but over here is negative 5 because we are moving 5 steps to the right. Okay? Or more like it is because the full story, right, is because this is 4.8 times 0.00000001. Okay? And this thing over here is 10 to the power negative 5. Okay, oops, sorry, it is 0.0001, like that. Okay, so that's the full story. Okay, now one last one over here, 0.0000000000167. So this last one over here, we have 3, 6, 9 steps, and then 10, right? So over here would be 1.67 times 10 to the power negative 10. Okay, so if you, yeah, so I think like the easy way is to look at by threes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, like that. Okay, number two is the reverse process where we want to convert it back to our ordinary notation. So 1.325 times 10 to the power of 6 times 10 to the power of 6. So what does this mean? The full story is 1.325 times 6 zeros behind. Alright? Times 1 million. So where will this fall? So I have 1.325.000. Okay? Like that. Okay? Then for B, I have my 4.4 times 10 to the power of negative 3. So the full story is I have 3 zeros over here. Alright, 0.001. Sorry, I have my 4.4 times 3 zeros, so 0.001. So this thing will be equals to 0.0044. Okay, like that. Okay, let's do a very quick double check. We have 1 step, 2 steps, and 3 steps to be 4.4. Okay, like that. Okay, and so this one over here, this rule and this shortcut over here, right? This shortcut over here, alright, is actually to convert. So this one, disclaimer, is not always to the left, to the right. So it is when you convert from ordinary, right, from the ordinary notation to the standard form. Okay, because if you can see, right, in question 2, if you were to move left and right, it doesn't work. It's actually the reverse. Okay. Okay, so this is for practice now 15. Okay, so this next part about talking about standard form is that we may encounter prefixes, alright, when we come to our standard form or scientific notation. And the importance of our prefixes, right, is also to instead of using instead of using standard form like 10 to the power of something, we may use prefixes to help us to denote like the important milestone. For example, how many megabyte, how many kilowatt hour, how many nanometers, for example, diameter of an atom, how many nanometers, how many milligram, alright? So we will be using these words, these prefixes, right? Prefix meaning like it's attached to the front of a quantity. Okay, so milligram, megabyte, kilometer, right? So the prefix will be in front. Okay, you fix the thing in front, and then it will tell you roughly the number or the size of the thing. Okay, so let us take a look at what are the prefixes that we have. So over here, as you can see, the only odd one out is actually our centi, right? The only odd one out is our centi. The rest, if you were to notice the power, right? The powers are of multiples of 3. It can be positive 3, negative 3. So it will be multiples of 3. Okay, I think because these are usually the milestones where we write numbers, we usually write in 3 zeros. Okay, I think that is, I don't know why, but I think someone came up with this system and everyone just decided to follow it. Okay, now then for the prefix, we start off with terabyte. So I think a good way to remember the positive ones are using computer language. So terabyte, gigabyte, megabyte, kilobytes. Okay, so you got these four on top. Then you have centi, milli, micro, nano, and pico. Okay, so the symbol is something that we will need to pay a little bit more attention, because these are so we don't get confused with what's going on. So tera is going to be a big T, giga big G, mega big M, kilo small k. Yeah, okay, so a bit different. Centi would be C, milli would be M, micro would be mu. This is the Greek letter mu, right? Nano and pico. Right? How do we write mu? Is like this thing with a tail and a U. Okay. Alright. So in case you are not too sure, this would be, for example, cm, mm, km. Okay, something like that. Okay. So the C, the m, the c, the k. So all these prefixes come from this concept over here, and we put it before the quantity. So okay. So the big question is, do we need to remember this? The answer is actually no need. Thankfully we don't need. Usually they will give the what do you call this, the amount of the prefix. Okay, so this one not to worry too much. But for us, like especially if you are doing science, this will be good to take note of. Okay, alright, so let's take a look at practice now 16, page 81. Okay. Okay, practice now 16, page 81. Okay, first question. Okay, external hard drive has 4 terabytes, and then you want to express it in bytes. Not too accurate, but here we go. So 4 terabytes. So 4, I'm going to write as 4 TB. Okay, or 4.0 TB. Okay, and 4.0 TB, right, is just 4.0. The tera is 10 to the power of 12. Okay, and this will be my bytes over there. Okay, so this is my question A. Right? Question B. The diameter of a human hair is 25.4, right? 25.4 micrometer. So I'm going to write as micrometer. Okay, given that 1 micrometer is 10 to the power negative 6, so 25.4, the micro, this micro over here will be 10 to the power of negative 6 b. Okay, sorry, n. Okay, and now let's take a look. 25.4, is it in standard form? Not yet, because 25 is more than 10. We want a number less than 10, so I will have 2.54 times 10 to the power of negative 5 meters. Because my decimal moved to the left, my power will increase. Okay, like that. Next one, C. A rain gauge measure rainfall over a period of time. The average annual rainfall is 2340 millimeter. Convert this to centimeter. So we have 234 centimeters. So I think this is a very straightforward conversion, right? Just divide by 10. Okay, from millimeter to centimeter. And in order to write as a standard form, this would be 2.34 times 10 to the power of 2 cm. But do we need to do that? Actually, don't need yet. Okay, don't need yet. For this one, we can just leave it like that. Okay, so not everything needs to be in standard form. It's just that when it comes to when you have a power behind, especially when you have unavoidable powers like that, okay, then it will be good to write in the standard form. Okay, yeah. Okay, so with this, let us take a look at the textbook, page 82. Okay, page 82 of our textbook, and let's take a look at most of the time, right, we will need to calculate each of these in standard form. Okay, and we may need to use the help of our calculator, but sometimes our calculator may or may not give you the correct the correct thing. So what we need to do is where do we find the first thing is where do we find the button to 10 power of? It's actually beside the equal and the answer sign. On the left of the answer sign, over here there is something times 10 to the power of x. Okay. Okay, so over here, okay, as you can see over here, right, this one over here, okay, this one is beside the equal sign, beside the answer, this one over here. So let me try and do a few of these so that we get the hang of this. So over here, the first one, we have our, okay, so the first one, we have our, okay, wait, sorry, let me do this over here then. Okay, so we have our 1.14 times 10 to the power of 5, right, times 4.56 times 10 to the power of 4. So this will give us this value over here. And how do we convert, right? We will need to write this as, right, 5.1984. And let us count how many steps do we need to move to the left, okay? So we will need to move, okay, it's behind, okay. So we need to move, I think like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be times 10 to the power of positive 9. Okay, so if we move to the left, it's a positive power. Now, next one, we have 4.2 times 10 to the power of negative 4. So we can just do this, right? This button over here. And then we times 2.6 times 10 to the power of 2. So what we get is 273 over 2500. We convert to decimal. This would be equals to 1.092 times 10 to the power of negative 1. Okay, because we move one place to the left. Oh no, my calculator too big. Calculator too big. Okay, like that. I think hopefully still can see. Okay, like that. Okay, next one we have okay, let's do a slightly challenging one. Let's do G. We have a fraction 2.37 times 10 to the power of negative 3, right, plus 3.25 times 10 to the power of negative 4. Okay, and then the bottom would be 4.1 times 10 to the power of 5. Right, so over here we have this ungodly number. So we can write this as 6.57, and let us write this in standard form. 10 to the power of 369. Just nice. 10 to the power of negative 9. Okay, so yeah, so this is an exercise of using calculator where we need to be aware of this one over here, right? The existence of the 10 to the power of, right, which is this one over here, right? This one over here. Okay, all right. Okay, so with this, we move to our very final portion of the lesson today, which is practice now 18. Okay, and for practice now 18, okay, let's just jump straight in. And we are applying standard form in real world context. So this is a SD memory card, 512 megabytes. Each photograph has a size of 640 kilobytes. So assuming that 1 megabyte is this, 1 kilobyte is this, how many photographs can this memory card store? Okay, so what we're going to do here is we're going to take the number of capacity divided by each photograph. So the total capacity, okay, wait, so number of photograph, okay, number of pictures or number of photo, okay, over here is equals to the capacity of the thing, capacity of the SD card divided by the size of each photo, right? So this makes sense, yeah? So how much capacity I have? 512 megabytes. And then the size of each photo would be 640 kilobyte. Now can we divide this straight away first? No, we have to convert everything to a common unit. So it's either we convert everything to mega, convert everything to kilo, or we can just convert everything back to the ordinary notation. So over here we have 512. Mega is 10 to the power of 6 bytes, right? Then 640 kilo is times 10 to the power of 3, and then we have our bytes over there, right? The bytes and bytes will cancel, right? And using our calculator, we have 512 times 10 to the power 6 divided by 640 times 10 to the power 3, we have 800 photos. Okay, so this is right, so this is one application of our memory, the standard form, and also the prefixes. Okay, so with this, the summary of the day is we have two different concepts that we're learning today. First concept would be standard form. We have to write a number in this form where this number A is between 1 to 10, right? Cannot be 10, but strictly less than 10, can be equals to 1, and we express as 10 to the power of something. So this n would be our order of magnitude that you see in your signs before this. Okay? Yeah. Okay, then another thing that we did was prefixes. Prefixes as an extension of standard form. Okay, so that would be this is a very simple lesson, although a long lesson, but a very, very simple one. Okay, so hopefully you get used to these numbers and you can just rely on our calculator for all our calculations. So that's all for the day. Thank you so much and have a nice day ahead.